In this episode, we're going to play around with Ansible via 4 Vagrant virtual machines. We will install Ansible from scratch, troubleshoot SSH connectivity issues, review configuration management files, and try our hand at common commands. Before we dive in, I thought it might make sense to quickly review what this episode series is about. In Part 1, episode number 43, we looked at what Ansible is at a high level, basically a comparison of doing things manually versus using configuration management. In this episode, we're going to get hands-on with Ansible by looking at patterns for solving common sysadmin tasks. Then in parts 3 and 4, we're going to take it to the next level by deploying a web cluster and doing a zero downtime rolling website deployment. If you haven't already watched episode number 42, where I gave a crash course on Vagrant, then I highly suggest you do that now. I'm going to assume that you know what Vagrant is, how it works, and that you have a working setup on your box. The reason that you need Vagrant is that we're going to build a multi-node Vagrant testing environment, where we can play around with Ansible to get a feeling for how it works. That being said, you don't actually need to download these demos today, but I've put together a number of supporting examples so that if you wanted to play around with Ansible on your own, there should be nothing stopping you. Let me show you what we're going to be building today by way of a couple diagrams. Hopefully you'll remember back in part 1 of this episode series, I tried to drive the point home about Ansible being installed on a type of management machine. This will typically be your desktop, laptop, or some type of well-connected server. Then from there, you will use Ansible to push configuration changes out via SSH. Well, in this episode, we're actually going to create a Vagrant virtual machine, install Ansible on it, and we'll have that act as the management node. But we're also going to create 3 additional virtual machines, and they will be our example client nodes managed by Ansible. I should mention, Vagrant actually has an Ansible Provisioning option, but it requires that you install Ansible on your local machines outside of the Vagrant environment. I chose to make an additional virtual machine inside our Vagrant environment to act as the management node, rather than having you install software onto your local system. The reason is that the management node aspect of Ansible only works on Unix-like machines, so if you have Windows, you won't be able to try the demos out. I also hate installing software onto my local machine just to try something out, and I really wanted to make sure that this was a turnkey solution for anyone wanting to play around with Ansible. Our Vagrant environment is going to look like this, with the management node created as a virtual machine, sitting alongside our client test nodes. There are a few benefits to this setup too, in that our Vagrant environment used to learn Ansible will be cross-platform, totally isolated, and you do not need to install anything onto your local machines, so we're totally free to test destructive changes. I have bundled the Vagrant file and all supporting demo files into a compressed archive which you can download via the links below this video. You can download it and extract it into a new directory, which will be used as your Vagrant project directory. I've already done that on my machine and put it into a directory called E45. In the supporting examples archive, you'll find 3 files and an examples directory. We'll take a look at these files in just a moment. First, let's check the Vagrant environment as defined by our Vagrant file by running Vagrant status. And as you can see, there are 4 virtual machines defined, a management node, a load balancer, and 2 web servers. These machines are all in the not created state, so let's fire them up by running Vagrant up. This will launch our 4 machines into our Vagrant environment, install Ansible onto the management node, and copy over our code snippets used for the examples. I sped the video up a little here. This actually took about 3.5 minutes to boot in real time. Now that we've launched the Ansible test environment, let's run Vagrant status again, and you can see that everything is in an up and running state. The just launched Vagrant environment has 4 virtual machines, the Ansible management node, a load balancer, and 2 web servers. I used a Vagrant bootstrap post-install script, which I'll show you in just a minute, to install Ansible onto the management node, configure a host inventory, along with moving example code snippets over to be used in the demos today. This gives us a turnkey learning environment in just a matter of a few minutes, and my hope is that you'll find it really easy to use and get going. The motivation for all this is that we can quickly stand up an Ansible test environment where you can execute ad hoc commands and eventually playbooks against our client nodes to get a feeling for how Ansible works in real life. Now that you've seen how easy it is to launch this Vagrant environment, let's check out how this works under the hood by opening up an editor and viewing the supporting files. The README file has an overview which provides a basic manifest along with links back to the episode series page. The Vagrant file defines what our multi-node test environment looks like. The examples directory contains code snippets, which are used throughout the demo section of this episode series. Vagrant allows you to boot virtual machines, then execute a shell script right after, using something called the shell provisioner. we use this shell bootstrap provisioner on the management node to install Ansible, copy over our example code snippets, and add some host entries to simplify networking within the environment. I just wanted to quickly review the Vagrant file and bootstrap script so that you have an understanding of how this all fits together. This might also come in handy next time you need to create a test environment, say for example for one of your projects, as this is a pretty common pattern which can be reused. The Vagrant file is where our 4 virtual machines are defined, and you will notice 3 blocks of code here. One for the Ansible management node, one for a load balancer, and the final one is for our web servers. I thought it might make sense to work through what each of these blocks does, starting with the management node. We're telling Vagrant to define a new virtual machine, using the Ubuntu trusty 64-bit image, set the host name to management, configure a private network address. This will allow all of our virtual machines to communicate with each other over known network addresses. Next, we set the virtual machine's memory to 256 megs. This should work on most of your machines as I've tried to keep the resource limits down. Finally, we tell Ansible to run our bootstrap management node script. This downloads and installs Ansible, deploys code snippets for our examples, and finally adds the etc host file entries for machines in our Vagrant environment. Next, we configure a load balancer virtual machine. For this episode, we're just going to use this as a regular client node, not a load balancer just yet. In parts 3 and 4 of this episode series, we're going to configure this node as a HA proxy load balancer using Ansible, and then set up a bunch of web nodes behind it. It should be a pretty cool Ansible example use case. We do pretty much the same thing here. Set the image to use, configure the host name, define a private network address, configure a port map so that we can connect to the load balancer, and set the memory limit. The port map line is likely the only interesting bit here. This maps a port from our machine running Vagrant to the load balancer virtual machine. This is really useful for testing network connected software, or in our case, for parts 3 and 4 of this episode series, testing an HA proxy load balancer with a bunch of web nodes behind it. The last block here is almost exactly the same as the load balancer block, except that we have this each statement here, which allows us to set the number of machines we want to launch via this number range. This is a bit of a trick, but it allows for a number of web nodes to be launched rather than having many duplicate code blocks for each web box. You can read this Vagrant tips page about it. In this episode, we're only going to launch 2 web servers. However, in parts 3 and 4, we're going to bump this number up as we play around with the load balancer. Hopefully at this point I've explained with enough detail how we launch our 4-node Vagrant environment. This is a pretty generic Vagrant pattern that I use for all types of tests, so I really wanted to show you how it works in the hopes that you'll find other uses for it too. Now that you know how our Vagrant environment is configured, let's check out how Ansible gets installed onto the management node, along with the host inventory and our example code snippets. The Ansible documentation site has some great instructions for getting Ansible up and running. I just wanted to cover this before I show you the management node bootstrap script, so that you have a fairly good idea of how all this is working. There's actually many different ways to install Ansible. These include installing from source, using the operating system package manager tools like apt or yum, and then there's brew and the pip installers too. I always prefer to use the operating system package managers when possible, as it just makes my life easier not having to maintain multiple package management systems. Ansible is very proactive in making sure that these various repositories have the latest version, so you're not at a disadvantage using apt or yum over a source code version hosted on GitHub. I've copied these 4 commands here, since we're using Ubuntu, and use them in our management node script. Let's jump back to our editor and see how this is triggered. When we launched our Vagrant environment via the Vagrant file, our management node boots and references the bootstrap script as a type of post-install script. The idea being that you put commands in here that will help you configure this vanilla Ubuntu trusty 64-bit box into something a little more useful. The 4 commands from earlier, off the Ansible documentation site, are actually really simple. First, we install a supporting package, add the Ansible software repository, update the package cache, and finally install Ansible via apt-get. Next, we copy over the code snippets used for the demos. I'm not actually going to talk about this too much here, as we'll cover them in detail later. Finally, we add host values to our management node's etc host file. These correspond to the preset network addresses in our Vagrant file. You don't have to use host names, you can use IP addresses with Ansible too, but I like to use host names as it just makes things a little more personal and easier to understand which machines you're talking to. Now that you have an idea of how all this fits together, let's head back to the command line and test the Vagrant environment out. We can log into the management node by running vagrant ssh mgmt. I thought it might make sense just to show you around the management node quickly by running commands like uptime, getting the release version, just so that you can get a lay of the land. We're logged in as the Vagrant user and sitting in the Vagrant user's home directory. If you list the contents here, you can see a wide variety of files. The files prefixed with E45 correspond to episode 45, so we'll be looking at these files in this episode. In episode 46, we'll look at deploying a web cluster using HAProxy, Nginx, and these playbooks will be used for that. Then in episode 47, we'll look at doing multiple rolling website deployments across our cluster of Nginx nodes fronted by the HAProxy load balancer. If we run df, you can see that we have our trademark /vagrant mount. This links back to our host machine in our project directory. If you list the directory contents, you can find the supporting scripts used to launch this environment, just in case you need to copy anything over. Now that we have a basic lay of the land, let's check out how Ansible is installed on this machine, and what some of the configuration files are that you'll likely need to know about. For our first interactions with Ansible, we're just going to be looking at ad hoc Ansible commands. Then we'll look at automating things through the use of Ansible playbooks. You can check out the version that you have by running Ansible --version. Depending on when you run through this tutorial, you might have an updated version from what you see here, since the Bootstrap script will download and install the latest Ansible version available. When you first get started with Ansible, you'll likely want to edit something called the Ansible config file and then the host inventory file. When you first run Ansible, it will check for the Ansible config file in the current working directory, the user's home directory, or the master configuration file located in etc Ansible. I've created one in our Vagrant user's home directory because we can use it to override default settings. For example, I'm telling Ansible that our host inventory file is located in /home/vagrant/inventory.ini. Let's have a look and see what the inventory.ini file actually looks like. You might remember from part 1 of this episode series that the inventory.ini file is made up of machines that we want to manage with Ansible. A couple things are going on here. We have a LB group here. This is for our load balancer box. Next, we have a web group, and this is made up of web 1 and 2. So these are our active web nodes, and then down here you can see a bunch of commented out ones. These will be added in parts 3 and 4 of this episode series. You might be wondering where these IP addresses and host names actually come from. Well, our Vagrant file assigns a predetermined IP address to each box. Then our Bootstrap post-install script adds these known entries to the etc host file, and that gives us name resolution for the hosts in our inventory. We can verify connectivity by pinging some of these machines. Let's ping the load balancer. Yep, seems like it's up. What about web 1 and web 2? Great, they're both up. This is one of the things that I absolutely love about Vagrant, is that we've configured actually a pretty complex environment with just a couple of scripts, and it's easy for me to send it to you. I just wanted to briefly touch on why we're using our own Ansible configuration file along with inventory.ini file, because this will hopefully round out our understanding of how to override defaults in the environment. In this environment, we want Ansible to use our custom inventory.ini file, so we need to modify the defaults. You can find the Ansible stock configuration files located in etc/Ansible. Let's open up the Ansible configuration file for a second. It is actually pretty long and there's plenty of tweaks that can be made, but the one thing that I wanted to point out was this comment section up at the top here. You notice that Ansible will check for the ansible.configuration file in the current working directory, a .ansible configuration file in the user's home directory, or the global configuration file located in /etc/Ansible, whichever it finds first. So when we run ad hoc commands with Ansible, or playbooks, it knows to look in the local directory for an ansible.configuration file, rather than the stock defaults. You can also check out the Ansible configuration manual page, and it has a breakdown of all the various tweaks that can be made. There's also the Ansible Best Practices Guide, which talks about using version control too, and there's tons of other tips in here. I highly suggest checking these pages out as they're just packed with useful guidance. As we heavily discussed in part 1 of this episode series, Ansible connects out to remote machines via SSH, and there's no remote agents installed. One issue that we need to deal with is when we have not connected to a machine before, you'll be prompted to verify the SSH authenticity of that remote node. Let's test this out by SSHing into Web 1. You can see that we're prompted to verify the authenticity of Web 1. Well, on the first connect, this will also cause Ansible to prompt you and likely give you an error message. Let me just show you what I'm talking about. Let's run Ansible web1-m ping. This uses the ping module to verify that we have connectivity with a remote host. As you can see that we're prompted and then given an error message saying that we can't connect. I could accept this, but what happens if you wanted to connect to 25, 50, or say 100 machines for the first time? Do you constantly want to be prompted? Granted, you might not run into this issue in your environment, as you likely have already verified the authenticity of these remote machines, but I wanted to discuss how to deal with this just in case it comes up. You could turn off the verification step via the SSH config file. What about manually accepting the prompt? Or you can use Ssh Key Scan to populate the known host file with the machines from your environment. Let's run Ssh Key Scan against Web1, and you can see that Web1 returns two SSH public keys that we can use to populate our known host file. This will get around the authenticity issue, and it's a quick way of accepting these keys manually, and we still have protection against man-in-the-middle attacks going forward. So let's run Ssh Key Scan LB for our load balancer machine, Web1, and Web2. Then we'll redirect the output into our vagrant users.ssh known host file. I typically like to verify that what I just did worked, so let's cat the known host file and see if it looks like what we expect it to look like. Cool, so we just added a bunch of keys from our remote machines. At this point, I think we're finally ready to dive headfirst into the Ansible demos. We actually already ran an ad hoc Ansible command when we tested SSH connectivity with Web1, but let's have a look at how that actually worked. The host inventory plays a key role in making connections happen. We basically already covered this, but any node that you want to manage with Ansible, you have to put into the host inventory file, just like our load balancer and web nodes. In this episode, we're going to explore a couple different ways of running Ansible. First, we'll check out using ad hoc Ansible commands. These are the kind of one-off things you'll run against clients. Then there are playbooks, which allow you to bundle many tasks into a configuration file and then run them against clients. We're going to check out playbooks in the latter part of this episode. You can run ad hoc commands by typing Ansible, then the first argument will be the host group or machine that you want to target. So if we said Ansible all, we would target all nodes available in our host inventory file. We could also say Ansible LB, and that would target the LB group, or Ansible web, and that would target all web nodes. But you can also target individual machines too by using their hostname, like Web1 for example. But in this example, let's run Ansible all-m. This means that we want to use a module. There's actually a huge list of modules that you can choose from. Actually, let's just have a quick peek at the documentation site for a minute. I actually mentioned this in part 1, but it's really important to how Ansible functions. You'll often hear the terms battery included when reading about Ansible. This is because there's over 250 helper modules or functions included with Ansible. These allow you to build ad hoc commands or playbooks to smartly add users, install SSH keys, tweak permissions, deploy code, install packages, interact with cloud providers for things like launching instances or modifying a load balancer, etc. Each module has a dedicated page on the Ansible documentation site, along with detailed examples. And I found this actually to be a major bonus to working with Ansible, in that it just works right out of the box. So in this example, we're going to be using the ping module, which is not exactly like the traditional ICMP ping, but rather it verifies that Ansible can log into the remote machine and everything is working as expected. I think of this kind of as the equivalent of a Hello World program for Ansible. Finally, since we're using SSH to connect remotely as the Vagrant user, we want Ansible to prompt us to enter a password. The password is just Vagrant, and I've overlaid it in the top right-hand corner of the video. Then we can go ahead and hit enter. Great, we get back this successful ping-pong message from each of our remote machines, and this verifies that a whole chain of things is working correctly. Our remote machines are up, Ansible is working, the host inventory is correctly configured, SSH is working with our Vagrant user accounts, and we're able to execute commands remotely. I'd like to demonstrate that connections are cached for a little while too. We can actually run the same ping command again, but this time remove the ask password option. You will notice that the command seems to run a little bit quicker, and that we're not prompted for a password. Why is that? Well, let's have a look at the running processes for our Vagrant user. And as you can see, we have 3 processes, one for each of our remote machines. Let's also look at the established network connections between our management node and the client nodes. You can see that we have 3 open connections, and they link back to the process IDs we talked about earlier. And if we turn name resolution on, you can see that we have connections from the management node to Web1, one to our load balancer, and finally one to Web2. Keeping SSH connections around for a while greatly speeds up sequential Ansible runs, as you remove the overhead associated with constantly opening and closing connections many times to remote machines. A very common use case will be that you want to establish a passwordless access out to remote client nodes. Say for example in a continuous integration system, where you're deploying application updates on a frequent basis. A key piece of that puzzle is to establish a SSH trust between your management node and the client nodes. What better way to do that than with Ansible itself via a playbook? Let's check out the E45 SSH add key YAML file. I'm just going to cat the file contents here, and then we can work through what this playbook does. Then we can run it against our client nodes. This is what a pretty basic playbook looks like. You can name the file anything you want, but they'll typically have a .yaml extension. There is actually a great manual page over on the Ansible documentation site that goes into a crazy amount of detail about playbooks. I think I've mentioned this before, but the documentation for the Ansible project is some of the best I've seen for all configuration management tools. Very clear and easy to understand. The one cool thing about playbooks in general is that they're basically a configuration file, so you don't really need to know any programming to use them. Let's step through this playbook and see what's going on. We use this host option to define which hosts in our host inventory that we want to target. Next, we say that we want to run these commands via sudo. You might be wondering why that's important to have here. Well, you'll typically connect via SSH as a non-root user, in our case the Vagrant user. Then you'll want to do system level things, so you'll need to sudo as root. If you don't define a remote user, it'll just assume that you want to connect as the current user. So in our case, we're already the Vagrant user, and this is a little redundant. But I just put this in here so that we could chat about it. Next, you'll see this gathering facts option. By default, facts are gathered when you execute a playbook against a remote host. These facts include things like hostname, network addresses, distribution, etc. Facts can be used to alter playbook execution behavior too, or be included in configuration files, things like that. Gathering facts does add a little extra overhead, and we're not going to use them in this playbook, so I've turned them off. The tasks section is where we define tasks that we want to run against remote machines. In this playbook, we'll only have one task, and that is to deploy an authorized SSH key onto a remote machine, which will allow us to connect without using a password. Each task will have a name associated with it, and it's just an arbitrary title that you can name anything you want. Next, you define the module you want to use. We're using the authorized key module here. It's a module which will help us configure a passwordless login on remote machines. I've linked to the module's documentation page in the episode notes below, and it provides detailed options for everything that you can do with it, but let's just briefly walk through what we're doing here. We're invoking the authorized key module, then we're saying that we want to add an authorized key through the remote Vagrant user. We define where on the management node we should look the key file up from, then we make sure that it exists on the remote machine. If we look on our management node in the .ssh directory, you'll see that we don't actually have this public RSA key yet. So let's just go ahead and create one by running ssh keygen-t. This specifies the type of key that we want to create. Let's just use RSA. There are newer key types out there, but RSA should give us the most compatibility if you have older systems that you want to manage. -b. This tells ssh keygen how long of a key we want. Let's enter 2048. If you're trying to do this outside of a Vagrant environment, be careful, because you don't want to overwrite your existing RSA keys, as this might cause you some grief. I suggest you use SSH Agent to manage the SSH key passwords for you, but this is a little outside of the scope for this episode. I plan to cover this in the very near future. For now, let's just hit enter a couple times without entering a password, and our key has been generated. Let's just verify that the keys actually exist by listing the contents of .ssh. And it looks like our SSH RSA public and private keys have been created. Let's just have a peek at the E45 SSH add key YAML playbook again. So now that we've fulfilled the requirement of generating a local RSA public key for the Vagrant user, let's go ahead and deploy it out to our remote client machines. We do this by running Ansible-Playbook and then the playbook name. In this case, E45 SSH add key. We also need to add the Ask Pass option, since we don't have passwordless login configured just yet. We're prompted for a password, and we'll just enter it like we did before, and rather quickly our Vagrant user's public key has been deployed out to all client nodes, which will allow us to connect via SSH without a password going forward. Great, so it looks like our SSH key deployment worked. Let's review what happened here. The task that we defined inside the playbook to install our management node's SSH key says that it changed 3 nodes, Web 1, Web 2, and our load balancer. You'll notice the name here matches what we had in the playbook. Then in our playbook, we asked to deploy the authorized key from the management node onto the client nodes. Then down here you can see that it actually changed on each of these remote machines. Finally, we're given a playbook recap. The recap section provides you with the OK, changed, unreachable, and failed tallies per node. Let's just rerun the Ansible Playbook E45 SSH add key command and remove the ask password option, as we're not going to need that anymore. You'll notice that in the previous playbook run, things changed, but the most recent run, the tasks all were green, and in the change recap, nothing was changed. You might hear the word idempotent or idempotence when working with configuration management software. What you're looking at here is a good example of it, and Wikipedia has a pretty good overview of what this actually means. Basically, Ansible scripts can be run many times in a row and nothing will change unless a change needs to be made. So in this example, Ansible is smart enough to check the client's authorized key file and see that it already exists, so it doesn't do anything. To ensure we're not piggybacking on a previously opened SSH session and that our SSH trust is actually working as we expect, let's run psx again, and you can see there's no active SSH processes connected out to our client nodes. We can also verify that there's no established SSH sessions between the management node and our client machines. Let's run Ansible all-m ping. So we're running an ad hoc Ansible command targeting all nodes, saying that we want to use a module, and then specifying the ping module. Looks like we're in good shape as everything is working as expected and without a password. So at this point we have all of these bits implemented. Our management node is up and running with a valid SSH install, and we have passwordless access out to client nodes, and we've verified that we can run commands. I know this has been a bit verbose on my part, but these are all issues that you'll likely want to resolve on your own. So I thought it would be worth the time to kind of explore and go through these issues together. You might be wondering, what everyday tasks is Ansible actually useful for? Good question. Almost everybody who comes into contact with Ansible will, at one point or another, typically want to install packages, push out configuration files, and start, stop, or restart services. So let's focus our effort on these types of things. Say for example that you wanted to install the Ntp package onto Web 1. Maybe the clock is drifting and we want to make sure that it has accurate timekeeping. So let's run Ansible web1-am apt-a name equals Ntp state equals installed. Some of this likely already looks familiar. We're running an ad hoc Ansible command targeting Web 1, saying that we want to use a module, and then we specify the apt module. The apt module allows you to install packages just like you would on Ubuntu using the apt-get command. There's actually a really great module documentation page that you can check out with all types of examples. And we're looking at the apt package module here, but this would also be functionally the same using the yum module, if say for example you're using a CentOS machine. I've included links to both these documentation pages in the episode notes below. Next we use the -a option, which allows us to pass an argument to the module we selected. So we're saying, make sure the package name Ntp is in an installed state. You'll also notice that we're doing this as the Vagrant user, as we have not said sudo, meaning that what we're about to run is going to fail, since the Vagrant user does not have permission to install packages without sudoing to root. I just wanted to run this so that I can show you what an error looks like. And after running the ad hoc command, we get back a message all in red, and it's pretty good indication that something went wrong without actually reading anything. We can see that the apt-get install failed, there's a permission denied error, then there's this little note down here asking if we're root. Well, we connected as the Vagrant user and tried to install a package, so this is to be expected. Let's rerun the command and this time append the --sudo option. This will tell Ansible that we should run the apt-get command as root, so that the package will actually be installed correctly. This time we get back a nice green message saying that the change state is true, with a long message from when the package was installed. And if we go ahead and run the command again, nothing should be done, as the package has already been installed. Now that you know how to install packages, let's go ahead and deploy a configuration file for the Ntp service. Included with the supporting material that you downloaded is a files directory, and I've included an example Ntp configuration file. I'm just going to type the ad hoc command, and then we can work through what it's actually doing. You should start to recognize commonalities with other commands we've run before. Ansible web1-am copy -a source equals home vagrant files ntp.conf, destination etc ntp.conf, mode 644, owner root, group root, --sudo. So we're running the ad hoc Ansible command targeting web 1, saying that we want to use a module, then we specify the copy module. The copy module allows you to, you guessed it, copy files from the management node out to client nodes. So we're saying copy this source file, which we look up here, set the destination to etc ntp.conf, then set the mode, owner, and group for that file. Finally, since we're connecting as the Vagrant user, we need to sudo to root, since the file is actually owned by root. After running the command, we're returned a green successful message saying that the file was changed along with a bunch of metadata about the change. You can run the same command again, and this time you'll notice that we did not change the file but verified that the file is actually correct. So that kind of handles installing packages and deploying configuration files, but what about stopping, starting, and restarting services? Well, there's actually a module for that too. Let's run Ansible web1-m service-a name equals ntp state equals restarted. We're using the service module to restart NTP over on Web 1. This is a pretty common pattern for deploying application stacks out to remote machines. Install a bunch of packages, push out configuration files, then restart the relevant services. We can also rerun the command, and this time, since we use the restart state, you'll notice that it always changes, but you can play around with the different states yourself. To be honest, you're hardly ever going to use ad hoc commands to install packages, deploy files, or restart services, as the workflow fits much better into playbooks. I just wanted to illustrate to you that the option is available via ad hoc commands, if you wanted to, and it works well in examples to build up our knowledge of how Ansible functions. There is, however, one ad hoc command type that you'll likely get much mileage out of, and that is running shell commands via Ansible. I'm just going to type the command and then we can review what it does. Ansible all-m shell-a uptime. And you can probably already guess what's going to happen, but let's work through it. We're using an ad hoc Ansible command targeting all nodes on our host inventory using the shell module, which allows us to run remote commands, and we want to execute the uptime command. We'll return the command output from all our machines in the host inventory. You could also limit this to various groups or individual machines if you wanted, but let's change the command from uptime to something like uname-a. Or maybe you wanted to reboot all web nodes. Say for example that there's a cooling failure in your data center and you need to power off all the machines in a particular cluster. Obviously this is an extreme example, but you kind of get the idea where I'm going. What I've shown you so far has mostly been an illustration of what you can do at the command line using Ansible. But to be honest, this can be a bit cumbersome as you're essentially doing things manually by way of typing things out. This is still a huge improvement over doing things manually by logging into each of the client nodes one by one. But we can do better by moving the package, configuration file, and service pattern into a playbook. We already had limited interaction with playbooks by deploying our SSH authorized key out to the client nodes. But let's check out what deploying a package, configuration file, and toggling the service state looks like. My personal take on playbooks is that they give you a way of bundling these ad hoc commands and associated options like sudo into a configuration file. Kind of like running commands at the terminal versus using a shell script. It's the same concept. If we list the directory contents on our management node again, you will see 4 playbooks for this episode. And you already know what the E45 SSH add key one does, but let's check out the E45 Ntp Install Playbook. Let's just cat the file and we can work through what it's doing. And since the ad hoc modules are reused, you likely already know what most of this stuff does. First, we specify that we want to target all hosts, just like we did on the command line where we were targeting Web 1. Next, we say yes that we want to sudo. This is because we're installing packages and deploying configuration files into places like Etsy and restarting services. What is cool about this is that there can be a separation between root and regular users who want to use Ansible. For example, in many shared hosting environments, you will not have root access. But if you're not deploying applications into places that require root, you can still happily use automation tools like Ansible. And this is a little different than other configuration management tools because we're only using SSH. Not that this cannot be done with other tools, but I'd put forward the idea that this is something that isn't commonly done by default in other tools. Again, we're going to disable gathering facts about these machines, as we're not going to use any of them just yet. I'll show you this in just a minute though. Next, we get into the tasks section, and this is where things should start to look familiar, as we pretty much run all of these at the command line already. The first task definition installs the Ntp package. Task definitions typically span 2 lines, and the first line will be the name or title of the task. Then you'll have the module for the task that should be run on the second line. In our case, we're using the apt module, which we discussed earlier, and pass along the argument string making sure the package is installed and that we update the apt cache. The next block looks pretty much the same. We have our task title, specify our copy module, define the source and destination along with the file modes. Something new here is this notify restart NTP bit. This actually is pretty cool. So you might remember back when we were running our ad hoc commands that you can run the same command over and over, and things will only change if something needs to be changed. So if this file has been detected to change, On a copy over via an Ansible run, it will notify this handler. A handler's job is to run some type of action. In this case, we're going to restart NTP. You can actually read all about handlers on the Ansible documentation site, but basically these are used as a type of trigger to fire off some type of event when something happens. The goal here is to say, for example, we update the NTP configuration file. We can run this playbook and it will know that NTP needs to be restarted via this handler, and it will restart the process to get our new configuration file settings. Handlers have the same formatting of tasks, just that they can be called from other tasks to do interesting things. The final task here is that we want to make sure NTP is started. Chances are that it will be, but let's just make sure anyway. This is basically just a more advanced version of the package configuration file and service pattern that we reviewed using the ad hoc commands, but in playbook form. We can run it by typing Ansible Playbook, then the playbook name, so E45 Ntp Install. Okay, so our playbook is run through the 3 machines in our host inventory. We could have targeted a narrow group of machines too, but it's more fun to work with a group of client nodes. The pattern here is really useful for laying down a common build or standard package set across a large number of machines. For example, say that you're running a data center with a few hundred machines, and you'll likely want common DNS settings, NTP settings, syslog going to a central server, keys and accounts, security tweaks, all these sorts of things. Ansible is perfectly suited for deploying these types of changes. So let's work through what the output is telling us here. First, we install the Ntp package across our nodes. And you will notice that we already installed NTP via the ad hoc commands earlier on Web 1, so nothing was done there. But for Web 2 and LB, NTP was installed. Same thing happened for deploying the configuration file. Web 1 already has it, but Web 2 and LB were updated. Next, we make sure NTP is started. Finally, Web 2 and the load balancer tripped off the notify handler because the configuration file changed, so it triggered a restart of NTP. The play recap gives us a tally of the state changes for each of our client nodes. For example, Web 1 already had the updates via our ad hoc commands, so nothing changed there, but the load balancer on Web 2 changed. This is useful for seeing at a glance what was updated. Then you can go back and look through the output if something triggers your interest. As usual, let's just rerun the playbook to see what the output looks like when nothing changes. And as you can see from the new recap, nothing was changed, and our environment conforms to what the playbook defines. Think about this for a minute. This is vastly superior to doing things manually, as we can quickly churn machines into what we want, verify that they're configured like we want, but not only that, we have a self-documenting playbook, which outlines step by step how it was created. This is lightning years ahead of doing things manually. And we haven't got into the really cool stuff yet. But this just kind of outlines the workflow and the benefits that using configuration management can provide. I thought it might be useful to create an example based around handlers, as this is something quite common in the workflow of a sysadmin. You will have a change request come in where you need to tweak a configuration file, then update a bunch of nodes with the latest configuration file. So let's work through what something like this would actually look like using Ansible. We already deployed the ntp.config file from the file subdirectory on our management node, but say for example that you wanted to change the NTP servers that each of our client nodes uses, then deploy the change out across our infrastructure. Let's open up the ntp.conf file using vi. So let's say we wanted to replace this server block here with something a little more specific to our environment. For example, I live in Canada, and so I went over to ntp.org and found the server list for my country. And it says here you can just copy and paste these into your NTP configuration file. So let's head back to the editor and paste them in. Okay, so we've updated our file. Now what? Well, let's just use our E45 Ntp Install Playbook again, as it already has all the logic we're looking for. Mainly that it deploys a configuration file, and that if it's changed, it triggers the handler, which will restart NTP. Let's give it a shot by running Ansible Playbook E45 Ntp Install. Cool, so that you can see that our updated NTP configuration file was deployed, and since it changed, our handler was notified that it needs to restart NTP, so that we can reload the configuration file. If you've not used configuration management, something as simple as this could be a real pain point, but Ansible turns this weakness into a strength. We're going to finish off this episode talking about facts, variables, and templates. As they're all interrelated, it really helps to have a base understanding of what Ansible is and how playbooks function before exploring this topic, so that's why I've waited to the end to talk about them. What are facts? Well, we briefly talked about them when we looked at our example playbook at the beginning of this episode, because we turned off gathering facts. But when an Ansible playbook executes against a remote machine, a task will launch, and it will gather facts about the remote machine. These can be used for all types of things, but let me just show you what they look like before we go any further. We can run an ad hoc version like this, Ansible web1-m setup. Then we're just going to pipe the output into less so that we can page through it. So we're running the setup module against web1. Moments later, we're presented with a ton of facts about the remote machine. Things like the IP addresses assigned, boot information, disk partition, detailed network configuration information, things like MAC addresses, and the list goes on and on. So what would you actually use these facts for? Well, in parts 3 and 4 of this episode series, we're going to be building a dynamic load balancer configuration file, which will use IP address facts gathered from our web server nodes so that we can direct traffic to them. Let's jump back to the command line and try some ad hoc commands by using the filter argument passed to the setup module. Let's say, for example, that you're running a playbook against a cluster of machines made up of Ubuntu and CentOS boxes. You might want to have some logic in the playbook that says, if the distribution is Ubuntu, run the apt module, but if the distribution is CentOS, then use the yum module, something like that. Let's add the argument option and pass in filter equals Ansible distribution. So you might want to run this across a bunch of machines to gather some statistics. Say, for example, that you're trying to do some sort of inventory based off of a fact. You can also grab facts using the star character. Rerunning the command, you'll see all facts matching the name. Before we did an exact match, but the star character allows you to grab everything with that name, which is nice if you're not exactly sure what you're looking for. Let's run the filter against Ansible all IPv4 addresses. And you'll see a list of IP addresses Web1 is listening on. I don't want to cover this too much here, but I just wanted to introduce you to the concept, and we can develop it further in parts 3 and 4. Okay, the final thing that I wanted to show you is templates. I've created a playbook called E45 Ntp Template, which is actually very similar to our E45 Ntp Install Playbook. Let's just cat the contents and work through what's happening. So we're targeting all nodes, using sudo, and not gathering facts. These next two lines are actually something new. Variables are basically custom facts that you can define. So in this case, I'm defining a fact called Hoc Ntp server. This might be useful if you had an internal Ntp server that you wanted to point your client nodes at. The only difference between this playbook and the Ntp playbook is that we are using a template module instead of the copy module. The module argument even looks the same, with the exception of this J2 extension here. J2 stands for Jinja2, and it's a Python templating engine. Ansible has also written Python, just in case you didn't know. The template is also included in the episode supporting material under the files directory named ntp.conf.jinja2. Let's cat the file and see what it looks like. So the first line up here looks like a comment. I just added this as the Ansible managed fact will output a bunch of data about how this file was generated. We will see this action after the playbook run. You can include facts or variables using the fact name, then these two curly braces around it. Down here, you'll also notice that the server section has been replaced by the Hoc Ntp server custom variable. This will take the variable from our E45 Ntp template playbook and insert our predefined variable or custom fact. This is useful for moving configuration out of files and into the playbook. It's a bit of a personal preference. The idea is to add custom variables into playbooks rather than digging through configuration files. And it's not uncommon to see tens of custom variables in more advanced playbooks. Let's just peek at our playbook again and see the custom fact defined. And at the top of the screen, you can see where it will be replaced via the server Hoc Ntp Jinja2 template entry. Let's go ahead and see what this does by running Ansible Playbook E45 Ntp Template. At this point, you should probably recognize what most of this stuff is doing by now. But our NTP configuration file was updated on the remote node and a notification trigger fired off to restart the NTP service. Templates will likely make much more sense if we just go ahead and log into Web1 and have a peek at the etc NTP file. What's so cool about this is that we've been installing packages, tweaking files, and restarting services without actually ever logging into this machine. So let's just cat etc ntp.conf. Right away you'll see the comment at the top of the file. That used to be our double curly braced Ansible fact. It gives useful information like the file was generated by Ansible, where the template lives, when it was modified, who modified it, and on what machine. Then down here you can see our custom server entry with the Hoc Ntp server fact inserted, which we defined in the playbook. So that's basically a crash course on facts, variables, and templates. Let's exit Web1 and head back to the management node. I thought we could come full circle and clean up our environment by removing the Ntp package from the client nodes. The final example for this episode is the E45 Ntp Remove Playbook. Let's just quickly take a look at what it does. At this point, hopefully you understand everything that's happening here. Our lone task is making sure the Ntp package is absent on all client nodes, and we can execute it by running Ansible Playbook E45 Ntp Remove. So we just remove the Ntp package from all nodes, and if we rerun the playbook, nothing should be done, meaning that the Ntp package has been wiped off all client nodes. By now, hopefully you have a pretty good understanding of what Ansible is all about, how it works, and what you might want to use it for. I mentioned back in part 1 of this episode series that the bar is set pretty low for working with Ansible. I think we also worked through some examples where configuration management really excels when compared to doing things manually. Ansible is not a silver bullet, in that you still need to create playbooks and work through problems, but it will make things much easier as time goes by, as you'll develop an arsenal of useful playbooks and one-off commands to solve your problems. Well, that wraps up this monster of an episode, and we covered tons of material, so hopefully you found it worthwhile to watch. So if you're ever interested in playing around with Ansible, you have a supporting Vagrant File, Bootstrap script, and a bunch of examples to work through. Be sure to check out parts 3 and 4 of this episode series 2, where we deploy a web cluster and configure an HA proxy load balancer. Then in part 4, we do several rolling website deployments across the cluster. Alright, that concludes this episode. Thanks for watching. If you would like to get notified about future episodes, please subscribe to my mailing list. You can do this by going to the Get Notified link in the header and entering your email address. Have questions, comments, or concerns about this episode? What about episode ideas? I'd love to hear your feedback, either good or bad. Shoot me an email, justin@sysadmincasts.com.